Can everyone hear me now? Okay.
Yes.
Okay, we apologize about that. Um, I'll go, I'll basically just to review what I was saying is that um a lot of this you can read, but I apologize about that volume issue. But we just want to get to know the data a little bit and look at the categorical and numerical variables. So I was just saying that this data is from Kaggle, and the number of observations and number of variables is as follows. And you can look at the variable names and types. And this data is just saying it includes some features that might influence student test scores. So you can see there's math score, reading score, and writing score down at the bottom, which are going to be our variables of interest. Then we import the necessary libraries and we load the data set. Then we can view the data. So that's basically all that I had said. So we'll continue from here. So you can see that there's an unnamed column, a gender column, ethnic group, parent education, lunch type. You can see all of the features that were described earlier. And we see some missing values. The NAN is a missing value, and we see that throughout the data set. So we're going to have to do something about that. You can scroll to see the rest of the variables. You can also view the data shape just to see the number of rows and columns, but it also says when we describe right here. So we're going to start by cleaning the data. We're going to check the counts of unique values per column. And we see that this unnamed column has 1,000 unique values. So it looks like it's some sort of student ID, which is not necessary for our analysis. So we're going to drop it from the data set. So all you do is just drop, and then we can view the data again without that unnamed column. So this is just that same data, the first few rows of it. And we still see some missing values. And we also notice that there are a lot of categorical variables, and there are only a few numeric columns. So we're going to check to make sure that none of the test scores were inputted incorrectly. So we're going to make sure that they range from 0 to 100. So this is the code just to check that. And just to make sure, because somebody may have inputted a score incorrectly. So we just want to make sure that there's no crazy outliers there, but we'll check some box plots in a little bit to see what some of the outliers are. But this is just to make sure that all of the test scores range from 0 to 100. So that is true. We don't have to worry about that. We're going to check for missing values. So we're going to run a code to see if we have missing values, and that'll determine if the data is missing or non-missing. And when we have missing values, we either want to drop those values or impute the data. So essentially, to decide what to do, you want to check the proportion of missing values per column. If the proportion is low, you can drop the rows with missing values or impute using simple methods. If the proportion is moderate, you should impute using advanced methods such as MICE imputation, MICE, but that's a little bit outside of the scope of this workshop, so we're not going to be looking at that today. And if the proportion is high, then you're just going to drop the entire column because imputing can compromise the nature of the data. So you always want to check the variable properties. They should be the same before and after the imputation. So we're going to check the percentages of missing values. So this is how you check the percentages. And then you just multiply by 100 to get the percent value. And we see that we have some missing data. We have 6%, 6%, 5%, all the way down to 10% missing for the transport means column. And we see that 10% is fairly low, so we're going to impute using simple methods. Typically, that's what you want to do unless you want to drop the data, or as we said, impute using a more complicated method, but we're not going to talk about that today. So to keep things simple, we're going to impute using the mean for numerical imputation and the mode for categorical imputation. So we're going to look at the distribution of each variable before and after the imputation to make sure the distribution stays a similar shape. And we'll do that a little bit. We're going to show you how to look at the distributions of the variables for the automated process portion of the workshop. And you can look and see, we'll create some histograms before and after we impute the data, and you can compare and make sure that the distributions remain the same. But we have mostly categorical variables, so we're going to use the mode for those categorical columns, and then the mean for the numeric columns. And you can also use the median. So we're going to first separate the categorical and numeric columns. So you want to take what's an object and what's a number and separate those two. And then we're going to create a clean copy for the data set to for when we clean the missing values up. So to impute the missing values, as I said, we're going to try the mode for categorical and mean for numeric. And this is the code that allows you to do that. And then afterwards, we can check to see if all of the missing values have been filled. And we see that there are no longer any missing values in any of the columns. So that's good. We can continue our analysis now. So the next thing we want to do is encode the categorical variables, because we have to, Python has to use numbers in its analysis. It can't always use categorical variables. So we're going to use one-hot encoding. And a little note about this parameter: if you want to reduce multicollinearity, you can set that to true. But we set it to false just so that you can see all of the different data columns. So let's take a look at this. We have number of siblings, which was already numeric. Math scores, these were already numeric, but then gender female and gender male, we've transformed these. So you can see it's a set of ones and zeros. So typically ones mean yes and zero means no. So you can see that this particular student is female and not male, and they don't fall within ethnic group A or B, but they fall within ethnic group C. And so you can play around with that and determine different attributes of those students. And we can describe the data set here in a table form with the count, mean. So this is the clean data set so far. So we have the count, mean, standard deviation, minimum, 25%, 50%, 75%, and maximum. And this gives you all of the variables that we have encoded and all of the numeric variables as well. So you can just find some information about that. For example, the count should all remain the same throughout all of the variables, because we dealt with missing data and we imputed, so we didn't drop any data, and just so they should all have the same number of rows. And you can look into see the mean, and then first quartile and third quartile.
Hello, everyone. My name is Inwan Jung. I'm going to talk about, static visualization. Visualization is an important step while, knowing about the data set we have, and we can learn about the statistical properties of the data set, and we can visually and easily notice the shape of the data's distribution and detect any skewness and assess the tails of the distributions. Since statistical analysis often relies on distribution assumptions, so visualization should not be overlooked and is highly recommended during the exploratory data analysis. Also, visualization helps identify outliers and recognize the data types, such as the cross-sectional data or time series data and longitudinal data. And you can have insights into the potential modeling approaches. For example, multiple linear regression should follow the normality assumption. So you can check the normality assumption to see the data distribution. So in this workshop, we introduced the following the visualization method: histogram, box plot, scatter plot, quantile plot, shortly QQ plot, and correlation matrix, and time series plot. Before we visualize our data set, we need to import the following important libraries: Matplotlib, and Seaborn. And I'm going to use the same data set, the clean exam score data. And let's start with the histogram. Histogram is a flow to describe the numerical values of data using a lot of bars. Each bar represents how frequent the numerical values are within the range. Bar's height represent how many data points belongs to the corresponding range. So next is a single histogram. I write this code to create the histogram, and PLT can create the histogram, and I use the variable in the exam clean data set. I set the bins to 50. For example, if you set the bins to large number, maybe the 100 or 80s, you can see there's a smooth distribution to represent all intervals, and the bars are colored green with the black edges to see the distribution more clear. And I'm labeling the x-axis to math score here, and I'm labeling the y vertical axis to count, and you can adjust the font size using this option, and I set the 20, and you can adjust the tick in the horizontal lines or vertical lines, and I set the font size to 16. And if you want to save this histogram, you can use this line, and you can save these images at the designated the folder. And the last line means to create these images. Next histogram is a multiple histogram, and if you wanna check a lot of features distribution, you can use this multiple histogram. And first line means first line is to set the figure size and 20 by 30 inches, and the second line is the number of columns. I set the number of columns to 4, and you can see there's future warning messages, but this is from the technical issues, not the coding issues. So you can run this code without these future warning messages. So I set the number of columns to 4, and you can see the 4 columns of this subplot. And I set the number of columns to this equation. This equation means to make this equation make a enough space to a lot of features, and using this equation you can this code can make enough space automatically. So this column means the making the enough space for subplots. And next, for looping commands, you can create the multiple histogram of each variable. And second line means the this code create the multiple multiple histogram of each variables and non-columns and non-rows and non-columns, and the seaborne HIST plot means to generate the histogram using this data set, and X equals column means the features in the data set, and you can change the color using this option. And you can change the color, maybe a red or yellow, something like that. And you can set the bins to 10 to 20, anything you want to set. And I'm labeling horizontal axis or vertical axis, and you can change the tick size to using this font size option. And this line means this line can prevent the subplots from the overlaying. So if you write this code, these multiple subplots cannot be overlaid. This is the function of this function. This code have the function, and this PLT show is to create this multiple histogram. And next is a histogram by groups. If you want to compare the two histogram based on some kind of indicator variable, for example, if you wanna compare two exam score based on the male or female, and you can use this code. And first line is to set the figure size, and the rest of them are the same. The one thing is different is this line, and you should drop the jailmail variable, because a jailmail variable is the reference variable to compare the two variables distribution. And this function is important to generate the multiple histogram by groups. And HU equals gender male is define the gender male as the reference indicators. So the rest of them are the same as before, and you can see this histogram gray area overlaid between two distributions. So you can this area make it clear make it clear to compare the two variables, and a gray area means the overlay the area between the two variables, and you can see the common property of each variables. So this is the multiple histogram by groups. And next plot is box plot. Box plot is a plot that visualizes the spread and the skewness of this data distribution, and also you can detect the outliers. You can use the boxes to represent the data points within the interquartile ranges, and a line inside a box means the median. You can see that these images, and you based on this data distribution, you can make this box plot. And as you can see, there are two lines in the box plot, and this line and this line is called the whiskers. And the whisker shows the data ranges within the certain limit, and you can the certain limits can be calculated with the interquartile ranges and the first quantile and third quantile. And outliers are typically shown as the individual dots beyond the two whiskers. And this is the box plot, multiple box plot, and I'm using the numerical variables such as number of sibling, math score, reading score, and writing score, and you can see the same process and number of columns, and col means the variable in the data set, and the num rows is the same as before. And the one thing you can see that is one thing different is that the SNS box plot code, and you can Y means the data set. Y means the variable in the corresponding data set, and the color, you can change the color using these options. So you can set the title, and you can labeling the y axis, and you can label the x axis, and you can change the ticks on horizontal or vertical lines. So the rest of them are the same before. So you can see this multiple box plot. And this is the library. This is the outliers. And this is the box represent the data ranges between the 3 quartile and the 1 quartile. And next plot is the scatter plot. Using the scatter plot, you can investigate the relationship between two numerical variables. And each dot represents an observation, which is a position according to their values on the x and y axis. So the following is the single scatter plot. In this code, I'm using the cleaned exam data, and I selected the reading score variable, and this is x, and this is y, and dark color is blue, and alpha can change the transparency in these dots. If the dots are overlaid, the transparency is very low, very clear. So the transparency is very low. So you can overlay the gradient of colors as clear, more noticeable, so more dense. And then you can see the relationship between the math score variable and the reading score variable. If you want to add the regression line, you can use this programming code, and you can see the coefficient of this coefficient of this relationship, and then the relationship the regression line is based on the ordinary least scale method. So you can see the relationship and using the regression line is very easily. Yeah. And next is a multiple scatter plot. And I'm using the this data set, and I selected the 3 variables of interest, and I set the 2 columns, and the rest of them are the same as before. And the different thing in the code, different things in this code are, this line, and the X is the data set. The X is a variable in the data set, and the Y is the this line is it is mean the writing score, and that's ILOC mean is the index location, and this hyphen is hyphen means the all observation, and -1 is the last one. So yeah, you can set the Y as the dependent variable. So that this line is to create the subclass, and you can change the alpha. You can change the alpha value for transparency, and you can define the XY variable. So yeah, that's these are the multiple scatter plot, and you can add the regression line to see the relationship between the 2 variables. Next plot is a QQ plot. QQ plot, quantile, or differently saying, quantile plot is the plot to assess whether the data distribution comes from the specific theoretical distribution, such as a normal distribution. You can compare 2 probability distribution based on this QQ plot, and one distribution comes from the sample data, and the other distribution is a theoretical distribution. And each data point is plotted based on their orderly quantile, and some data points deviate significantly from the straight line. It suggests that the data distribution may be skewed or not follow the theoretical distribution that we expect. For QQ plot, we need to import this sci-fi stat library, and this is the single QQ plot. And I'm using this stat PROB plot code to use this math core, and this option means the theoretical distribution is the normal distribution. So anything else is the same as before, and you can add the grid in this plot using this plt.grid and the true. And this is the QQ plot of math core. As you can see, data points in this area deviated from the straight line, and this suggests that the data distribution are skewed or don't follow the theoretical distribution. Next is a multiple QQ plot. As I said before, the structure of the code are the same as before. So you can use this code to create your own plot using your data set. And one thing different is this subplot. And this subplot operating while this looping process, and you can this code is to create each QQ plot of each variable. And this stat problem plot indicate the code used the normal distribution, and then this QQ plot create the multiple QQ plot based on the variables in the exam clean data set. And the rest of them are the same before. And next is correlation matrix. A correlation matrix is the correlation measures the directional relationship between two variables. If the correlation coefficient is close to 1, there is a positive relationship between two variables. And if the correlation coefficient is close to -1, the relationship is negative, which means an increase in one variable leads to a decrease in the other variable. A near zero correlation coefficients means that there is no correlation. To generate a heat map of correlation matrix, first you should calculate the correlation matrix, and I'm using the numerical variables such as number of siblings and the test scores, and this CORR code can calculate the correlation coefficient, and these are the results. And based on this result, and you can generate this heat map. I have a technical issue with this heat map. In my laptop, I can see the all correlation coefficient values on this in the middle of the box. So here there are the values on the first row, but if you wanna see all of the correlation coefficient, you can run this code at home. Yeah, you can see all of the correlation coefficient, and the gradient of colors means how strong the correlation relationship are. So you can use this correlation matrix to select which feature is important. So the correlation means the relationship between a pair of the variable. So this correlation matrix give us insight into the modeling approaches. Last one, Last one is a time series plot. Time series plot is time series plot shows the sequential data points over time. You can see the unusual events, and time series statistical property of the data, such as the stationarity or correlation relationship and variation across the multiple time series variables. And time series plot is very important to time series analysis and time series modeling, such as ARIMA or AR, MA, and longitudinal analysis. These are the data set I used, and I used the different data set from the FRED, and this is the Federal Reserve Economic Database, and using this you can import this library before downloading this data, and if it didn't work, you should install the Pandas data reader. So after that, you can use the economic data from the just the Federal Reserve Economic Data database, and then I extracted the unemployment data from the FRED, and this is my data. And using this code, I created a time series plot, and you can see during the pandemic there's a rise of the unemployment rate, so you can identify the irregular patterns of the data using this time series plot. By play through with this notebook, you can have a hands-on experience, and you can understand more about your data based on this whole of the visualization method. And yeah.
All right, so we're going to talk about some interactive visualizations. So we're going to go back to our test scores data set and create a 3D scatter plot for math score, reading score, and writing score. So I'll just show you the code there, but you can interact with this, which is pretty fun. And we can gain some insights. So here we have a student whose math score looks like 9. Their reading score is 23 and writing score is 20. So for this particular data set, if the student scores poorly in one area, they're going to probably score poorly in another area, and vice versa. If they're going to score well in one area, then they may score a little bit better in another area. So you can see how all of these are correlated. You can play around with that 3D plot. We can also build a Dash web app to interactively explore the data set. So below is an example of a simple interactive dashboard for the exams data set, allowing us to visualize scatter plots, histograms, and box plots dynamically. In this example, you can select different columns for visualization, and the code will display interactive graphs, which in this case are scatter plots, histogram, and box plots. So at first, this code may look a little bit daunting, but the nice thing about this is, if you ever want to use this app, you can just use all of this code, and the only thing you have to change is the data set that you're using. So we're using the clean data set, so anytime it says exams clean is when you could take this exact code and just plug in your data set, and we get some pretty interesting things that happen. So we can create a scatter plot. Let's look at math score and reading score. And you can see a scatter plot of math score and reading score. You can also click and pick any variable you want for either axis. Next, we have a histogram where we can select anything we want for the histogram. Let's say we want gender female. And in this case, we have gender male and gender female count, and you can see that it's a pretty balanced data set. You can barely tell the difference between the two boxes, but there is a slight difference. So that's pretty balanced between gender, and you can flip through and see parent education high school versus not high school. And you can look at a box plot as well. So this is a box plot for a number of siblings. You can see that the outlier is somebody had a number of siblings that was 7, and that's an outlier because normally we don't have that many siblings. And it gives you all of the information here. And again, you can click and on any column and it'll give you the box plot. So that's a pretty cool app. Now that we've done everything by hand, it's nice to automate the process for us. So there are some automated EDA processes that can do pretty much everything for you except for impute missing data. in this case. So we're gonna use pandas profiling. We're gonna look at the raw exams data, and then a little bit in a second, we're gonna look at the clean exams data. And we see, this is for the raw exams. You can scroll through and see that we have some missing cells because this is before we imputed. You can see again that the gender between female and male is fairly balanced. You can see that there's some missing data here. So it says missing up at the top. And what's pretty interesting about the numeric variables, I'm going to scroll down to test scores, is it'll say high correlation. This variable has a high correlation with two fields, and it gives you the high correlation. So we've kind of already established that math score, reading score, and writing score have a high correlation, but it's very interesting that it'll tell you that for you. Another thing I want to point out is this transport means. So this is the distribution of that one column that had 10% missing. So this is the original distribution. So you see a lot more school buses. And when we impute, we're going to see about the same distribution here in just a second. We're going to go to this is the code for the clean data set. Again, pretty simple code. All you have to do is change the data set and the titles. And it gives you the same information, but this is with the clean data set, so you're not going to see any missing cells. And I'm going to scroll down to that transport means. You can see all of these. That's interesting that there's a high correlation in lunch type. But essentially, if you scroll down to transport means, you're going to see the same type of distribution before and after we imputed the data, which is a good sign. So you can also play around with that. And this is my favorite of all. We saved the best for last. This is SweetViz. Pretty simple code. All you have to do is input the data set. We're going to do with the raw exams data first, and then with the clean data set. And this will show a little app here, but it also shows an extra tab. So we're going to go to this right here, and we can see, click on associations. And you can see some associations that it's going to be noting, which is interesting. So it's basically generates a correlation heat map. And writing score, reading score, it'll tell you how many distinct values there are, how many values there are missing, which we have some missing data because this is before we had imputed. And it gives the distribution and percentage of groups here. And then if we go back to the next line of code, this is the same thing, but just with the clean data. So it's either going to show up here or it's going to click, or both, open a new tab. And this is after we had imputed the data. And you can also click on associations to see all of the different, this is after we had separated the categorical variables. So I think this is very interesting that it basically does a lot of the EDA process for you. And you can scroll down and it's very interactive. Oops. And that is the completion of our workshop. If you will hang around for just 1 second, we do have some time for questions. And we also have a QR code that we encourage you to fill out, that will show us how we did on this workshop today and what future recommendations you guys have for us in the future. So if anybody has questions, you can hang around or ask them in the chat, and we'd be happy to answer those questions for you. Yes, so to answer your question, if you bring your own data, yes, we can't do analysis for you, but our lab can certainly help assist you in some statistical analysis. So yeah, just if you want to set up an appointment, we do appointments virtually and in person. Our office is located in Gilbreth 308M, and you can email us for our exact office hours, but most of the time it's around 9 to 2 or 9 to 3. And yeah, you're welcome to set up an appointment or just walk in. We also offer walk-in appointments. So we'd love to have you come in if you're interested in some specific statistical analysis.
Looks like there is a hands up for you in the chat. I mean, not in the chat, in the Zoom link.
In this, what was that? I'm sorry.
Oh, there's a hand up in the virtual platform.
Oh,
Somebody is
okay.
trying to ask a question.
Yeah, feel free to go ahead and ask that question. I'm not hearing anything, but if you
Yeah.
guys have any questions, you can always email us. We're gonna put our email in the chat. Okay, yeah, okay, so to answer the first question about the threshold of missing values, typically around 5% or less, you're definitely safe to impute using simple methods, and then anything above that, you probably want to use a little bit more advanced methods. We just didn't go over that today because we didn't think that that would be appropriate to go over in this workshop. But there are some more complicated imputation methods out there that are always recommended. Does that answer your question? Okay. And to the other question, I might need a little bit more information about your specific project. I'm not very familiar with. I would just need some more information. So you're welcome to come into the lab and talk to us about that. But let me put the email in the chat. Yeah. And we're located in Gilbreth 308M. Does that help? Yeah, just shoot us an email if anybody is curious about what else we can do. Perfect. And we can look at your specific problem and data set. We'll stay on the line for just a few more minutes in case there's any more questions, but just please fill out that survey. It would really help us out. If you can suggest future workshops. We do have a plan of what future workshops we're going to offer this semester, but just keep an eye out for those. But we're also looking for ideas for next semester as well. All right. Let me know if there's any other questions. Otherwise, I'll give you one more minute. Otherwise, I'll go ahead and end. Okay, thank you all so much. And just come to our office if you need any other questions or shoot us an email.